And we are now live on air. We are very privileged to have Sam Scimemi. I hope I've pronounced that correctly. Is that right?
Scimemi.
Scimemi. And you are Scimemi.
Scimemi, yes, you got it.
Okay. And you are the director of the International Space Station Operations. Is that correct?
Yeah, Director of the International Space Station at NASA headquarters.
Okay, so it's an official title, and when we spoke to Charles Bolden 2 weeks ago, he said that he's called the administrator, but actually he's the head. So you're kind of like the international curate.
Steve, you're completely breaking up there.
Sorry, are you like the head of the International Space Station at NASA?
So what my role is here at NASA headquarters is to direct all the policy and programmatics associated with the space station. The actual running of the space station and all the operations and all the day-to-day activities, talking to the crew and doing all that is down mostly at the space centers like the Johnson Space Center in Houston and and in Moscow with the Roscosmos Russian Space Agency facilities. So that's where all the day-to-day activities happen.
And how many people are actually involved in the space station?
Across the world, literally thousands of people are involved, not only in the operations, but also in the engineering efforts, the training, the planning, the building the hardware, and the like.
Okay, so I want to try and get a bit of a timeline going. When did you first get into all of this? And was this your first choice? Were you always wanting to be involved with NASA? How did it all start?
Well, it started when I was a kid, I guess. I grew up in South Louisiana, and I remember as a kid watching the Apollo landings, Apollo 11 and on the rest. And when I was in 8th grade, we took a field trip to the Johnson Space Center in Houston. And that's when I was about 12, 13 years old. I decided this is it. This is what I wanted to do, is to work at NASA.
Now, so you're saying that field trips are critical in perhaps awakening people, or do you think that the Johnson Center in particular is so fantastic that awoken your desire to be involved?
Well, I think the Johnson Space Center for me was a tipping point, but today there's a lot more opportunities now. There was no virtual visiting anymore. Back then, there was no opportunity to, like students today are flying spacecraft to the International Space Station today and doing their own experiments. We didn't have any of that when I was growing up. All we had was TV and newspapers and radio, right? So we didn't have the internet, we didn't have anything virtual. So I think there's lots of opportunities now for people around the world to participate in spaceflight.
Now, did you study towards a degree that says I'm going to be an International Space Station operator, or was it something a little bit more general? What sort of route did you follow?
So as growing up, I was always good with my hands. When things break, I love to take things apart. So it was a natural for me to go into engineering. So I have a degree in mechanical engineering, and when I graduated from university, at the time, back in 1984, the aerospace industry was not hiring at all. And I tried to get a job, but it didn't. No one was hiring either at NASA or the major contractors. So being in Louisiana, I went into the oil industry, which is a natural for there. So I spent a year and a half, almost 2 years, before I was able to apply for a job at the Johnson Space Center, and I finally got in. So if you don't, succeed at first, you got to keep trying, and that's one thing about working here, is that you really learn that many times things don't go well the first time, but you got to keep trying.
Absolutely. In fact, the administrator, he said, if anyone ever tells you that it can't be done, don't listen to them. If you're driven and that's what you really want to do, then you should pursue your dreams. So this is something that you really, really wanted to do. And then, of course, you get involved in this whole project, but you mentioned that you're not involved in communicating with the astronauts on a daily basis. You're not involved with the payloads, the things that are sent up from Earth to the International Space Station. So what specifically do you deal with when you are working on a program like the International Space Station?
So here at headquarters, well, we do actually interact with the program quite a bit. So all the daily operations, we're aware of what's happening, what the crew's usually doing, all the vehicles that come to visit the space station. So we're involved at a top level of knowing what's going on space station, basically. Our main purpose for here at headquarters, though, is to work with the policymakers at the White House. So like later today, I'm going over to the Office of Management and Budget to talk about our progress. I often go on Capitol Hill here to talk to legislators, to the Senate and to the congressional stakeholders about what NASA is doing and answering their questions about how money is being spent, how the taxpayer money is being spent on the space program.
Well, here's an obvious question. Why do we need a space station? What is the big deal?
So it is a big deal, right? It's a big deal, and it started way back in 1984, and it's something that the American people have wanted to do for a long time. This is something, we're a public agency, so NASA doesn't decide what we do. Actually, Congress and the White House, being a representative government, they decide on what we do. So way back in the Reagan administration, President Reagan was convinced that building an international space station was the right thing to do for the agency, and that's when it started, and Congress agreed, and we got funded to do it. So we've been on that journey ever since.
And who started it off first, and then who came in to join the party as it went along?
So space station was conceived by the United States. So Ronald Reagan, President Reagan, thought it was important to invite our allies at the time, back in 1984, to promote our values of our society here, and to be able to expand human spaceflight beyond and do all the research and things that to return the benefits back to humanity here through all that research and technology development. So the original partners were the United States, of course, Japan, Canada, and ESA, the European Space Agency. And in 1995, space station was redesigned, and under President Clinton, invited Russia to participate. And that's when we brought the Russian Space Agency, Roscosmos, into the program.
And now, how many agencies are actually collaborating on the space station?
There's 5 space agencies, Roscosmos, which is the Russian Space Agency, European Space Agency, ESA, the Canadian Space Agency, and the Japanese JAXA, the Japanese Space Agency, of course, NASA here. However, there's 13 countries, given that the European Space Agency has member countries. So there's 13 countries, 5 space agencies.
Wow. And I mean, how difficult is it to collaborate with so many different countries who have so many different values and priorities and budgets? How do you reconcile all of that?
A lot of hard work. Again, not only is the engineering difficult and challenging, but the relationships and the partnership was also difficult in the beginning to start. But once everybody got, I would say, comfortable with each other, whether it be Japanese or Russians or Americans or Europeans, having the experience together brought down a lot of barriers. Once you start trusting each other, we all had the same mission. Everybody agreed that what we wanted to do on the International Space Station. We all agreed that what we were trying to do in research and benefits to humanity and the goodness, if you will, out of the program. Everybody agreed on that, and it was just a matter of making that work. So, we've had this partnership now for decades now, and we've had astronauts on board space station now for almost 16 years, nonstop. Anybody who's younger than 16 years old, every day and every night of their life, somebody's been on orbit. That's never happened before. It's incredible.
How many astronauts have actually stayed on the International Space Station?
About 500.
So it's quite an elite group of people. It's a very small group.
Excuse me. That's 200. Sorry,
200. Even smaller than that.
200
That
people.
is incredible. And what I'm intrigued about is, obviously, you said that there are a lot of agreement in terms of the purpose of having the space station. But, you know, your preference for what sort of science experiments wouldn't necessarily match the preference for, let's say, for ESA or JAXA. So how do you just get together and say, well, we're all going to do science, we're going to do a little bit of that, or how do you actually arrange that?
Well, so that's what we call sausage making. So we actually have a process for that, actually, that the United States NASA coordinates with all the space agencies on a 6-month basis, what we call an increment. We do the planning, so it takes about 2 years to do the planning for a 6-month period on board space station. So basically, everybody puts their requirements in the jar, and then there's a group of people that sort of prioritize what each space agency wants to do, and then they map out a plan. And we've been doing this for years now, so we're pretty adept at balancing whatever everybody wants to do on board the space station.
But now, it's not a small little piece of equipment. How did you get all of it up there, and how big is the whole space station?
So the space station is about as big as a football field, whether it be an American or international football field. It weighs a little over 400 kilograms. So it's about a little over 100 meters across left to right, and about 50 meters front to back. So it's pretty big. It's as big as a 5 or 6 American bedroom house. It's fairly large inside.
Wow, and I've actually loaded the photograph up for those of you that would like to see it. You can just click on my little photo, and you should be able to see a large image of the actual size of the International Space Station. But once again, how do you transport all of that up? How many shuttle trips did it take to get all of that there?
So it took quite a few it took about 39 shuttle missions to ferry the U.S. portions and the original ISS partners, the Japanese, Europeans, and Canadians. And it took several more of Russian flights to bring up the Russian segment as well. So a lot of flights. Currently, there's about 15 flights to space station a year from around the world, from Russia, from the United States, from Japan, that supplies the space station and provides the capability to exchange the crews as well.
But now, if I recall, when things first started on shuttle missions and a few Soyuz capsules that were coming from Russia, now we have a little bit of commercial endeavors taking place. We have SpaceX and Boeing and a few other, I think Jeff Bezos is involved as well, and they're all starting to develop their own rockets that are delivering payloads. How is that going to change the schedule in terms of delivery of items and that type of thing?
So, you know, spaceflight is hard. So spaceflight will always be hard because of the physics and the technology that's required to get cargo or spacecraft or people into space. You're basically taking a lot of energy and in a short amount of time exploding it under astronauts, basically. What we are doing here in the United States is that we've contracted with private companies to actually bring the cargo to the space station. Right now we've got Orbital ATK and SpaceX delivering cargo to space station. NASA is basically not managing that. Those companies are managing that activity, and we also hired Sierra Nevada to do the same thing coming up here in the next couple of years. We're also working with Boeing and SpaceX on delivering crew from the United States, and we hope to have them ferrying astronauts to the space station in the 2017-2018 timeframe.
Well, that's what you say. I mean, there was talk about perhaps landing on Mars with a human crew in the 2030s, but Elon Musk has different plans. He would like to do it far sooner. So, I mean, you might have a planned schedule, but anything could change because of the technology and the rapid development within the industry.
Well, what I would say is that the hardest part to getting to Mars, one of the hardest part is not the capsule or the spacecraft. It is the systems that keep people alive. And NASA and the Russians, Space Agency, and the European Space Station, the Japanese Space Agency, it's only governments that have been making investments in the technology that keep people alive for long periods. To go to Mars and to come back is anywhere from 2 to 3 years. Now, to keep people alive independent of the Earth really has never been done before. Even on space station, we've got resupply missions and we fix the hardware on a regular basis. When you go to Mars, there's no resupply mission. There's no way to come back if things break. So it's not just about doing a demonstration of robotic or uncrewed. Uncrewed, the Russians started going to Mars back in in the 60s and 70s, and we followed them, and about half of the missions to Mars have failed. If you go look on NASA's website, we actually account for all the missions that have gone to Mars. About half have failed. So, and that's on the robotic side. Now, when we want to send people, well, we want better odds than 50-50. Much better odds. So, in order to build up that confidence, if you will, that technology and the capability to send people, we're just not going to send people and just flip a coin to see if they make it or not. It's not like the robotic missions where if the missions fail, nobody dies. So it's quite a bit different environment.
That's obviously a very serious undertaking and a lot of responsibility, because obviously the buck has to fall somewhere if things go wrong. That's right.
That's right. What's your backup plan? NASA's famous for having multiple backup plans, and it's not going to be no different than going to Mars. So,
well, we're going to be talking about Mars in a second, because you are quite involved with the Humans to Mars Summit, which is coming up in the next week or so, and I think you are one of the speakers there, if I'm not correct.
Correct.
And we're going to be talking about the implications of Mars and what have we learned from the space station that we could obviously apply to Mars. But I will definitely get onto that. I do want to ask a technical structure of that nature that is being maintained by only a few people over a long period of time. It is aging. And yes, you can replace certain parts, but I mean, most of the original parts are still there. I heard someone say that there was a plan to, at some point, say, listen, we're going to terminate this International Space Station and we're going to get it to crash land on Earth in the ocean, and we're going to put something else new, bigger and better. Can you just expand on that and tell me how accurate is that?
So, being a physical man-made object, the International Space Station, it will have a physical engineering life. It will not last forever. So right now we've done some analysis, and we think the key parts of the structure can last about to 2028. So that means all the interfaces that connect the modules, the truss segments, all the major elements of the structure have a life of about 2028, which is about 30-year lifetime what it was originally designed for. So around that time, we will have to decide: do we bring the whole space station into the ocean like that the Russians did with Mir, or do we actually reuse some of the elements that we have on space station?
I'll just put it on mute. Yeah, okay. But now, the parts that are on the actual International Space Station, the computers and all those sorts of things, you don't exactly have a service company that can come up and, oh, our laptops are down, can you please service? The astronauts are pretty much responsible for fixing everything.
So we have a lot of spares for everything on board. So if a laptop crashes and we can't get it to reboot, well, we have additional laptops. So things of that nature. And all that's actually managed on the ground by the space agency. So NASA manages its own equipment. ESA manages its own equipment. The Russians manage their own equipment. So all this, there are spares on board for practically all the things that's needed to keep not only the astronauts alive, but actually to conduct all the research and everything else that goes on. We also have the ability to repair things on board. Since we have people, they've got lots of tools. They've got diagnostic tools, they've got wrenches, they've got screwdrivers. I mean, they've got everything needed to repair many things that are on board the space station.
And for all our fellow makers, because I know that as a mechanical engineer, you certainly are a maker at heart, you guys have sent up 3D printers. And have they made use of them to print tools, or is that for the potential to print tools?
So they've actually printed one tool already. They printed a torque wrench that the astronauts couldn't find, so they needed to use it, and so they actually printed one out, and were able to demonstrate that a torque wrench could be used. Now it's just a plastic torque wrench. Obviously, we haven't got to metal yet, but that's in the future plan. So we've actually are going down that path to see how can we actually print tools or print parts on orbit that we don't have to now take all the parts with us.
Well, I mean, that's innovation for you. I mean, can you imagine, all of a sudden you need to solve a problem, and to get tools there instantly not going to happen, and now you can just create the tools. Do they design it on Earth and then send the plans up, or do they do the planning on the International Space Station?
I think the astronauts, they'd be probably overwhelmed if they actually had to design their own tools. So all that's designed on the ground, and the design for those tools or parts are actually uplinked to the space station, and then downloaded to the 3D printer.
How do they do that? You don't have a telephone cable running from Earth all the way to the space station. How are you sending internet to that space station?
Well, so just like any other space communications, we've got a space network called the TDRS system, which is a large spacecraft, several large spacecraft orbiting high above the Earth that we communicate to through a ground network here on the ground. So we have about 300 megabits of downlink capability, and I forgot what it is uplink, maybe close to 100 or 50 megabits uplink. So we have quite a sizable pipeline to communicate with the astronauts and the space.
And how long does it take? I mean, is there a delay when you are speaking to someone on the International Space Station?
It's all, for all practical purposes, it's instantaneous. There is a couple of millisecond delay, but in communicating, you just don't notice it.
It's negligible, so that's amazing. But now, everything doesn't always go according to plan, and there was some mention that there was a leakage of some sort of gas on the International Space Station. You watch these movies where something goes wrong and then they have to really think outside of the box. What happens when there is a problem like that on the International Space Station?
So we've had some issues, no actually real emergencies, but we had what was a false, what we call a false positive. We had a sensor that indicated that we had an ammonia leak on space station. Ammonia is used.
Not a good thing to have.
And it's not a good thing to have, right? And so we've got procedures for what the crew's supposed to do. So they did exactly what they were supposed to do. We have gas masks that they can put on, and they can go to a safe part of the space station and close the hatch. So all that was done, but then it turned out that it was a false alarm. So it was something. There was an error in the sensor and in the software that was controlling that sensor. So we've never really had an issue like that. Now on Mir, they had a couple of issues back in the 90s. If you recall, they had a fire on board the space station from an oxygen generating system, and they also had an accident with a Progress vehicle running into the Mir space station. But again, they had procedures. They had procedures for all that. So all that was thought of, and the crew had procedures on what to do about it.
And of course, being an astronaut, you know the risks if there is an emergency and you need to abort. That's just the way it goes, because preservation of life is far more important than the station.
And that's right. And we always have a Soyuz spacecraft for each one of the crew members that they all can come back down if someone either gets sick or has an injury or something. The crews can come back down in a matter of hours.
Now, was it built and designed that you had the escape pods, or are these the rockets that they came up with and they parked them there, and then all of a sudden you start adding more and more as you go along because there's lots of visitors?
So we're not Hollywood, so we don't have escape pods.
Okay.
So we actually, their escape vehicle is the vehicle they came up on. So they basically come up in a vehicle and they go down on the same vehicle. So those vehicles stay up there for as long as that crew's there.
But now, when a vehicle arrives and they need to park it, there's no garage. Where are they going to put this thing?
So the Russians have 4 docking ports. So and the Americans and on the U.S. side we have 2. So there's plenty of places to dock the crew vehicles and cargo vehicles. And the U.S. side has 2 places to dock crew vehicles and 2 places to berth cargo vehicles. And the Russians have 4 docking ports.
Wow.
So there's 8 places, basically 8 garages, if you will. 8.
And are they full? Have you filled them all up?
So right now, there's the Russians have got their 4 filled up, and we've only got 2 of ours filled up.
Okay.
At this current time, now, they're not always full like that. So this is like a special time right now where we have all these vehicles on space station at the same time.
All right. Now we're sending astronauts to go and live on the International Space Station, and as you would be well aware, Scott and his colleague, the Russian astronaut, the 2 of them spent a year on the International Space Station. What are the types of things that you've learned from his particular trip, and what have you learned in general about life on a space station as opposed to our own planet?
Well, they're really glad to be back, both of them. That's one thing right away. We had a whole science program for both Mikhail and Scott that they participated in, things related to body fluid shift, bone loss, muscle loss, and things of that nature. So all that research is continuing. So we're actually comparing the data right now from their stay on board space station as opposed to being on their 6 months, which is a regular increment for our crews. So they're actually doing that comparison right now. So the research is continuing. We don't have any specific results right now. It's going to take about a year for the scientists to sort through all the data and to do to do all the analysis. We're still doing science right now on Scott and Mikhail right now. So they're still drawing blood. They're taking their saliva samples and the like, and urine samples from both of them still, and they'll be doing that for weeks and months to come to see what the changes to their body. So that research is continuing. It didn't stop for them.
Did Miguel also grow as tall as Scott? I heard that they both grew quite a bit. Well, I don't know if they both did, but Scott grew quite a bit while he was on the International Space Station.
Yeah, so I mean, I'm sure he's back to normal size by now. But all astronauts grow some. It's not just a year-long mission. After you're there for a few weeks, there's a noticeable expansion of your spine. Wow. So it doesn't take a year. It just takes just a handful of weeks for that to happen.
Now, you've taken this space station, we've observed, we've done science on it, we've proven that we can have people living in space and doing it quite well. We haven't had any problems with the toilet, have we? I mean, if the toilet goes down on the International Space Station, what do?
We have backup toilets, don't worry.
Okay, just checking, just checking. So then one starts thinking, well, hold on, if we're going to go live on another planet, surely we can take the lessons that we've learned from the International Space Station and perhaps reproduce that on another planet, and then instead of living in space, we just live on that planet.
So you talked about the Humans to Mars conference. That's exactly what I'm going to talk about. So my presentation is actually what are we doing on space station to get us to Mars to be able to live off of another planet, actually to get there and get back. The hardest part is getting there and getting back and landing is another hardest part. Once you're on the surface, things that work on the Earth will also work on Mars. So you have gravity now. And you get some atmosphere, even though you can't, the Mars atmosphere is poisonous. You can't breathe it. So you have to bring all your own oxygen or make your oxygen when you're there. But so all the life support systems that work on the Earth, like in submarines and the like, will also work on Mars. So that's an easier problem to solve. we know how to do that because we're doing it here on Earth today. It's the space part. It's when things go into space, they work differently. Fluids perform differently. Heat transfer using fluids work differently. And there's a whole host of other physical sciences that work differently in space than they do on the Earth or in any gravity environment.
Wow. We had a question from the Astronomy Society in Grahamstown Roads in South Africa. Jackie wanted to know, what is the most exciting thing that has happened to you since becoming the director of the International Space Station?
Well, so that's a good question. I think the most exciting thing for me is probably a personal thing. My son got into college. So
that's awesome.
That's probably the most exciting thing for me. I think, you know, work-related, if you will. I think having this partnership and going and seeing how things sometimes fall apart on the Earth, but then having this partnership that's just rock solid between us and Europe, Russia, Japan, and the Canadians, to see this partnership really pull together and get through all the challenges that we've had to get through. So that's pretty exciting, actually, every day just to see how we actually pull together as a team, even though when things on Earth don't necessarily go that way. So I would say that's probably is an ongoing excitement for me.
Okay. Now, I mean, I'm not going to hog all the limelight here. I would like to give some of our audience members a chance to maybe even ask a question. And I think we're going to go to the Ivory Coast because it looks like they might even have a student there that would like to ask a question. Kim, do you have a student that would like to ask a question? So you must just unmute yourself.
Your name and where you're from. It's Ben right
here.
Go. Oh, say hi.
Hi. My name is Benjamin.
Hi, Benjamin.
Yeah. I have a question. When you're going to the Mars mission, would you use additional satellites to support your help with the rockets?
Yes. So that's a really good question. So yes, you would have to have additional satellites, communication satellites. You also have to have cargo spacecraft to bring all your supplies or your food or your oxygen, your fuel. So it's more than just the crew capsule or the crew spacecraft that would take you to Mars. So you need a lot more infrastructure to go to Mars than just what the crew members would fly in. Good question.
Okay. Thank you.
Good question. What's good question? Have you got another question in the class there?
Anybody else want to ask? What's your question? Come on up. Say your name.
My name is Ruben.
You gotta look up here.
Oh, sorry.
And speak loudly.
My name is Ruben.
Hi, Ruben.
So my question is, will the astronauts bring robots to Mars?
So actually, there's robots on Mars right now. The rovers are there right now, and when the humans go, we will also have robots that are doing similar things on the surface of Mars. We actually have robots with us right now on board the space station. The Canadian robotic arm and something that's called Dexter. It sort of looks like a creepy human with really long arms and long legs that looks something out of a sci-fi movie, but it's also a robot that helps us maintain the space station. So yes, we'll bring robots with us to Mars too.
Thank you.
Sure.
That was a good question. And maybe Mr. McCutcheon, I don't know if you guys are there out in I think it could be in Canada. Do you guys have any questions? Any of your students? We'll just see if Sean's class is able to ask a question. He's switching he's unmuting, he's muting. Let's have a look. Okay. Sean, have you got a question? Yeah, we can hear you.
We were just wondering about the Canadian involvement in the International Space Station, because Chris Hadfield certainly became a national hero here.
So the Canadians' primary contribution to the program is the Canadian arm, much like the shuttle arm. It's a very large structure that was initially used for the construction of the space station. It was critical. We couldn't have put the space station together without the Canadian arm. They've also contributed something I just mentioned called Dexter. It is a industrial robot with arms and legs and cameras and tools that's used to actually maintain the exterior portion of the space station. So those are his two biggest contributions.
Great, thank you.
Sure.
Good question. And of course, I mean, Chris Hadfield, you know, as you mentioned, he started a whole social media campaign, taking lots of photos, and I see that a lot of the astronauts now are taking the photos and the social media very seriously, because you guys are getting great exposure. I mean, it's been fantastic to see images of Cape Town, for example, that were posted. I think Tim Peake from ESA, he was posting photographs of when he came over South Africa. He took a photograph of the tip of Africa. And, you know, as people who are excited about math and science and space, obviously, to get an opportunity to see something that you don't normally get to see, I think that Chris was quite pioneering in his approach to doing that.
Yeah, that's fantastic. And many astronauts have come up and done the same thing, and whether it be singing songs or taking pictures or communicating via the ham radio system we had on board the space station. So there's a lot of ways that people on Earth have been interacting, if you will, with the crews on board. It's fantastic. The more people, I think, the more people that understand what the astronauts are experiencing, the better things will be here on Earth.
Would it be possible to do a Google Hangout with astronauts just like we're having over here?
Good question. Good question. So we're actually working on building an internet of space, actually. Now, the delay through the internet probably will be a little more difficult than we have here terrestrially. So there may be some technical issues as far as the delay over the internet. The reason why we can speak real time with the crew is that we have a dedicated NASA system that we communicate with the crew today. Of course, when you go over the internet, you're not. It's no longer a dedicated communication path, so you have to share it with other systems. But probably as technology advances, as the internet gets faster and faster, someday that would be possible.
Well, if you need a volunteer to assist you in the testing phase, just know that I'll be happy to try that out. I mean, we love trying to
get in line, right?
So now I want to go a little bit more into the whole Mars aspect, because Mars is obviously now the flavor of the month. The Mars Summit is going to be addressing the complexity of getting there, the difficulty in keeping people alive there and bringing them back safely. The distances are obviously a difficult component to deal with. So the lessons that we learn from the International Space Station are going to play an important role. Are we looking to build a station? Are we looking to build some sort of village? Or, I mean, what are the kinds of ideas that would come from your mind in terms of what you've seen from the International Space Station?
As far as going to Mars, or what comes after space station? What's it? I'm sorry.
I think once you get to Mars, and we're looking to stay on Mars, I mean, I can't imagine we're going to go stop there for 2 days and then spend another 7 months traveling back. I would assume that they're looking to obviously spend some time so that when the rotation of the planets is aligned at the right moment, then it's a short distance back again.
So what I would say, you probably have to walk before you can run, right? So lots of people have come up, and including NASA, have come up with these ideas about colonies on Mars, or these scientific research stations like on the Martian, right? That are on Mars. We're probably quite a long ways away from that kind of exploration activity. To keep humans on the surface of Mars requires a lot of electrical power, if you will, a lot. And you basically would have to have a nuclear power station on Mars to provide the power that you would need to keep the humans alive, run the systems, grow the food if you're relying on that. So we're probably a ways from that. We can use solar power on the Martian surface for, I would say, short periods of time and for low numbers of people. But if you're going to have a significant presence on Mars, you're basically going to have to go with a nuclear power system, and that's a big leap in technology to actually get something like that, launch it from the Earth, and then get it to Mars.
Okay, so it really is a very complicated process.
It's a very complicated process. If it's just robots, your options are more open. Today, the Mars rover today that's up there operating right now, it's got a nuclear power source. It's not fission. It's what's called RTG. It's just using the heat from the decay of radioactive material. But to get people to survive on the lunar surface, you need something like a nuclear power plant that we have here on Earth.
Okay. So, I mean, you obviously going to be addressing all these sorts of issues at the Humans to Mars Summit, which, for those of you who are not aware, is taking place from the 17th to the 19th. And over the next week or so, I will be interviewing a whole bunch of people that are involved in the summit. And you are welcome to join in on the Hangouts or watch it live on livingmaths.com. I'm intrigued to know, you kind of alluded to the fact that there was a lifespan to the International Space Station. So when it does reach the end, what are the plans?
So our intention, at least on the NASA side, what we would like to be able to do is, instead of the government deciding what's next, is have private industry decide what's next. What we're trying to do, like we're doing with commercial cargo and commercial crew, is to, if you will, mature industry so they're able to provide all the capabilities, all the habitation modules, the supplies, the crew transportation, do the research, and have private industry follow the government. Much like the U.S. expansion into the western part of the country, is that the government did all the initial funding of, like, the railroad, and then private industry came in behind that. So we're using that same sort of model that we want to, now that NASA and other governments have effectively built up a base of technology and capabilities, is that have private industry actually operate and manage systems after this space station. The government, what we're doing on our side, we're not only building growing the industry, but we're also developing the demand, like from other private industry, the pharmaceutical companies or biomedical companies, to actually have private research going on space in space after this ISS is over. And we've made a lot of progress through the National Lab and an organization we call CASIS to actually get private industry like the Procter & Gamble's, the Novartis, and companies like that to actually use space station for their own private research, and let that sort of be the market driver for what happens after space station.
So there is actually a commercial aspect where you could generate funds.
That's right.
For a project like this.
That's right. And that's our intention after space station. We'll see how far we get with that vision, but that's what we're working on today, and we're using the space station we have right now to actually realize that vision.
I mean, you could potentially look at it as a real estate opportunity where you build 3 or 4 larger space stations and make them available to private consumers and generate a great profit on that.
Yeah, and they could be large or small. They don't have to be big space stations. They could be just small space stations, or much like we had in the shuttle period, where the shuttle would go up for a couple of weeks and come back down. The companies we have today, like Sierra Nevada or SpaceX or Boeing, I mean, that could be a business model too, whether it be tourism or even doing research on short duration. Leaving this up to the private industry, now all those things are possible. It's not the government telling private industry what to do. Let private industry figure out what's the best thing to do.
Is there complexity in terms of principled issues with regards to what you are allowed to do commercially on the space station? So, for example, would you promote the testing of cigarette smoke and that type of thing? There might be or alcohol consumption. Are there issues that become the thin line between are we allowed to or are we not allowed to do that on the space station?
So, being a government organization, so the government is constrained by federal law on what the government can and can't do. So we can't do advertising, we can't do marketing. So that's a big constriction on what to do on space station. We can't do casinos and things of that nature. Now we can do research. There has been research, for instance, on what happens to barley used for beer what happens to barley in space and how that could be applied to actually growing better barley on the Earth for beer. That's actually been an experiment on space station. So there's been all kinds of things like that that are broader than just, if you will, medicine or other areas, but it's all in the research realm. So the government's, pretty much constricted to those kinds of things. We're doing research today on space station in earth science, space science, astrophysics, material sciences, the physical sciences, like fluids and flame and combustion, and we're also doing research to cancer and biological processes and the like. Research with fruit flies, zebrafish, like for muscular dystrophy, rodent research, muscle wasting and wound healing. So space station is a wonderful facility to do all those things, all on the same platform. What comes after space station, maybe we don't build one big to do all those things. Maybe you have specialized platforms that do those things. And,
wow.
So it's multidimensional, multifaceted. It's very it's quite complex.
Okay, now I can see that I know Kim's one of her students would like to ask a question. Are there any of the other panelists that would like to ask a question? We have MP Malone there and Samuel. If you want to ask a question, just unmute yourself and fire away. I don't see. All right, if they do, you can also type it in on the chat, and I'll be happy to ask the question on your behalf. I'll get to Kim's group now. From an educational point of view, there are a lot of exciting initiatives that are taking place on the ISS. For example, students can control a camera that takes photographs of specific spots that you can determine. There are robotics championships in zero gravity. There are obviously the usual experiments and things that you're doing, but involving students in citizen science. Can you maybe list some of the exciting opportunities that the average person could get involved with?
So, gosh, there's all kinds of opportunities on the education side. There's been students and educators from over 90 countries that have done activities on board the space station in either research or education activities. So it's just a plethora. I mean, I couldn't name them all. We've got a small company called NanoRacks that does a lot of outreach and getting student research on board space station. In fact, I was just in Las Vegas a couple of days ago where they were having a competition at the 5th grade level to fly their experiments on board the space station through a partnership with NanoRacks, for instance, which is a company that we have a Space Act agreement with to do such things. And NASA has its own programs as well. We have a lot of different challenges and opportunities for educators and students to actually interact with. In fact, I'll give you, for instance, we've had the first Vietnamese spacecraft was launched from space station through one of these same activities. It was from a university in Vietnam, and that was through the space station. So it's really exciting to see people from around the world actually do their student level, whether it be elementary school or high school or university or graduate studies on board the ISS.
That is very, very exciting. Now, we've got a little bit of time, so I want to ask Kim, one of your students, I can see that they are eager to ask a question.
Hi, Mr. Sherman. Yes, they're very eager. This is Sanvi.
Hi, my name is Sanvi.
Hello?
I wanted to ask, I'm in 6th grade. I wanted to ask you, how are pens used in outer space?
How are pens? Writing pens?
Yeah.
Well, astronauts often take notes, and sometimes they use notebooks, with paper, or sometimes they use their iPad and take notes in their iPad system. So just like you would here on Earth, they use pens exactly the same way.
But now, are pens not reliant on gravity for the ink to come down?
Now there are some pens that you can actually buy on the internet that have pressure in them to force the ink to the bottom of the to the writing part of the pen. So you can buy those today on the internet.
Or you could probably
Or
spring
could
for
you-
a little bit less with a pencil.
Or you,
That's very cool. Good question. That was a great question.
Another two in, maybe? We got two more.
Sure. Ask two questions. Absolutely.
A lot. Come on up. Armand is really shy right now, but he had a lot of good questions. So go ahead,
Hi,
Armand.
my
Hello?
name is Arman.
hello?
My name is Arman,
Sixth grade.
6th grade.
Hello. What's your question?
I was wondering, how does the International Space Station maintain its orbit?
So to stay, that's a really good question.
Very good question. Very good.
The station is about 400 kilometers above the Earth, and it takes a lot of fuel to keep it in that orbit. A space station is a very large vehicle, so it has a lot of atmospheric drag. Even though it's in space, there are still parts of the atmosphere, even at 400 kilometers. So we have to have a lot of rocket fuel on board the space station to maintain its orbit, and we do what we call orbit adjustments quite often to keep it up in space. Otherwise, it would come down by itself because of the atmospheric drag. Good question.
A great question. Okay, one more question from that side.
So, hello, I'm Brian. I'm in 8th grade.
Hello, Ryan.
And I heard somewhere that there was water on Mars. Is it true?
Yes. So we have found evidence of water on Mars, and we have not found water flowing like in rivers yet, but we have found evidence that water has flown on Mars, and that we have actually seen frost just underneath the surface of Mars. And frost, of course, is water vapor frost. So yes, there is water on Mars, but we have not found it in the quantities like you've seen it here on the Earth.
It's a very good question. But now, of course, you guys are growing plants on the International Space Station, and you're trying to harvest food in some form. You've obviously been looking after fish, but no livestock. There are no goats and sheep on the International Space Station. Is there something in the future?
No cats or dogs either.
Would you be looking at perhaps some sort of animal on board, mice and hamsters? And then also, what would happen, for example, when you have been growing the plants, have you been successful?
So growing plants, we've been quite successful at growing plants. We're still experimenting with the right medium, if you will, the right soil or medium that the plants grow in. We're trying different things. We're also trying different frequencies of light. Some plants do better in pure white. Some plants do better in red or purple light. So we're still experimenting with that. You may have heard that the crew just ate their first salad that was grown on board the space station. So I think plants will be an important part of astronaut life, if you will, when we leave the Earth-Moon system. Having more complex organisms like animals and the like, I think right now it's just limited to the research like fruit flies, zebrafish, and mice. I think it's just limited to that. Having larger, more complex animals would be quite difficult. It's not like you see in some science fiction movies where spacecraft are as large as cities and the like. Spacecraft today, and at least for the foreseeable future, are going to be small in nature.
Okay. Are there any more questions from the rest of the panel that would like to ask? No, they might be a little bit too shy. Okay, so for me,
any other educators or other students from other groups?
They might be shy, and I know that they might have been emailing questions through. I must just check my emails while we're chatting. But what I do find fascinating is that obviously a lot of effort and a lot of work goes into keeping this whole thing together. But there are certain things we can't predict. Something could impact. Space debris could impact with the space station. Now, there have been movies about these sorts of things, but is there a possibility that might happen? And the kind of damage that it could be doing might be serious.
Yeah, so first I want to explain that space is a really big place. What you saw maybe on the movie Gravity, it took a lot of entertainment liberties.
Okay.
Space is a really big place, but it is still a real possibility, and we take that very seriously. So NASA, again, like I said earlier, we have backup plans and backup plans to the backup plans. So the crew actually knows what to do in an event that something like that happens. If the station becomes uninhabitable, they will get in their spaceships that they came up with, and they would just leave. That's the plan. So they have portable oxygen if they need. If it starts to depressurize, they have their portable oxygen systems they can take with them. They have fire extinguishers on board the space station. So we have a lot of plans in case that event might happen.
Well, I mean, I know that the next person that I'm going to be interviewing just after you in about, let's see, half an hour from now is Alan Eustace, and he put on a spacesuit, traveled up with the weather balloon up to the stratosphere, and then just dropped down and landed on Earth with a parachute, which is obviously not a small task. But now, what would happen if there was damage to the Sawyers that have been docked? Is there a chance that they might be able to use jetpacks to get to Earth's atmosphere and then drop down and land with a parachute? Is that a possibility?
I think from a physics standpoint, it is possible. And it is possible. Now, from a technology standpoint, I don't think we're at the point yet where the technology is there to actually protect a person in a small environment. The plasma and the heating load would still have to be dissipated in whatever is encapsulating the astronaut. So it's quite possible. This has been theorized for many, many years, since the 50s, that this is possible. And in fact, there's an old U.S. space show called Lost in Space, and one of their initial episodes, the commander, Dr. Robinson, he does a space jump, actually, from the spacecraft onto an alien planet. So it's been thought about for a long time. Now, the technology that's needed to keep a person alive is not quite there yet.
Wow. Now, do you guys have a replica of the space station on Earth in case you need to go through it and say you need, because you watch the movies and you read the books and they talk about, you know, from a redundancy point of view, they have duplicates of everything on Earth, so they can tell you to move this piece here and move that piece there and do this and do that. Does that actually happen with you guys?
So the space station is actually too big to be built on Earth. So we have parts of it replicated on the Earth for training and for to troubleshoot things when things go wrong, but it's in pieces. So we have the avionics system, the computer system, if you will, is replicated on the Earth, but not in the same modules, if you will, that we have on board the space station. So it's in bits and pieces. We have trainers that do dedicated training for a portion of the space station. You know, for instance, the Russians have their training system and troubleshooting system in Moscow, and we have ours here in between Houston and in Huntsville, Alabama, at the Payload Operations Center.
Awesome, awesome. Now, what do you love most about your job?
The things I get to learn. Being here and in my position, getting to learn everything that goes on board the space station and within NASA, and to be able to interact with forums like this and to just give what I learn. I mean, I feel I'm extremely fortunate coming from a small town in Louisiana. For this to be a dream come true, to be where I'm at today, I feel very blessed and very fortunate to be able to do such. And
any advice that you would like to give the younger viewers out there, the students who might still watch this at a later stage, what should they know about getting into your line of work?
What I would say is that follow your dreams. Work hard at it, follow your dreams, but have a backup plan. Just like in anything in life, follow your dreams, work hard at it, but also realize dreams that are hard to accomplish don't always come true. But don't give up. but always have a backup plan if you can't reach your goal for whatever reason. Have something else that also makes you happy. You know, follow your dreams, follow what makes you happy. And not all dreams are meant to be, but you know, you still can live a very happy life with the second choice dream.
It's about managing expectations. I like that. I like that.
Expectations. You know, I'd love to be able to go to Rome every year. You know, but you know that's probably not going to happen at this point in my life, right?
You never know. You never know. Well, you can do it virtually, of course. Well, Sam, I just wanted to say thank you very, very much for taking the time to share your expertise and your knowledge and your enthusiasm for the work that you do. I know that I certainly learned a lot, and I'm sure that the students that are watching this live on YouTube are definitely walking away with and they're taking away some extra knowledge that they did not know before. I also know that the Human to Mars Summit, which is happening from the 17th to the 19th, is going to be a very exciting event. They've got some very high-profile people there. They've got the administrator of NASA, Mr. Charles Bolden. They've got Bill Nye. They've got Buzz Aldrin. So a lot of very exciting people, and we are hopefully going to be interviewing most of them over the next week. So if you would like to be a part of any of those interviews, just visit our website on livingmaths.com, and we'd love to include you. And I know that we're going to be interviewing Alan Eustace in about a half an hour from now. So if you'd like to be involved in that one as well, please shoot me an email and I will send you the Hangout link. So thank you very much for taking the time and for all those people who've joined us as well. And we wish you the best of luck for the summit. And we'll be looking out to hear all the exciting new things that are happening with the International Space Station.
All right, thank you, Steve, and Godspeed to everybody.
Can we take a picture?
Oh, yeah, you wanted to know. So Sam, if you could just smile at your camera, and then they're going to take a selfie with you in the background,
Right.
and I'll just quickly catch a screen grab as well. There we go. And they're just going to take a couple of photos with you in the background, and they'll send those through to us, and we can obviously post those on Twitter as well. Awesome.
All right, that it?
So now